Hello, my name is Tanner Rath, and I'm here today to teach you about some of the biggest chemistry breakthroughs. There are obviously way too many contributors to where we are today with chemistry to tell you about. Instead, I will give you the most impactful and important breakthroughs in chemistry instead. There are many more discoveries and breakthroughs that influence the world we live in today, but these are the ones that I consider most impactful. You can expect as a mixture of chemist discoveries and theories as well as inventions that change the way of modern day life. Let's get started. John Dalton's atomic theory, 1766 to 1844. John Dalton lived. John Dalton's discovery of the atomic theory was groundbreaking in the chemistry world. Dalton proposed that all matter was composed of atoms which were indivisible and indestructible building blocks. All atoms of a specific element were identical, but different elements have atoms of different structure, size, and mass. His theory also stated that compounds were composed of combinations of these atoms in definite ratios. Finally, the theory postulated that chemical reactions resulted in the rearrangement of reacting atoms. Avogadro's number. Avogadro lived 1776 to 1856. Amadeo Avogadro discovered that the mole gives scientists the ability to calculate elementary entities, which are most often atoms and molecules, in a certain mass given substance. Avogadro number is considered an absolute number, 6.022 times 10 to the 23rd power, elementary entities in 1 mole. This means that the mass of 1 mole of a specific substance is equivalent to the substance of the molecular weight. Max Planck's quantum theory. Max Planck lived from 1858 to 1947. In the 20th century, physicists discovered that the laws of classical mechanics do not apply to the atomic scale. We would need new laws. That is where Max Planck's quantum theory came in. Planck discovered that photoelectric effect could not be reasoned based on already existing theories of light. The increase in the light intensity did not lead to the same output of energy from the light. More simply put, Planck found that the atom was capable of gaining or losing very minimal amounts of energy, hence quantum, which means how much. Planck postulated that energy of a light is proportional to frequency and the constant relates to them, which is called Planck's constant. Planck is considered to be the father of quantum theory. His discoveries opened up many doors for other physicists and chemists. Antoine Lavoisier lived from 1743 to 1794 and founded the oxygen theory of combustion. Lavoisier discovered the role of oxygen in the combustion cycle. The theory was derived by a very demanding campaign to construct an experimentally grounded chemical theory of combustion, calcination, and respiration. Lavoisier studied the weight gains and losses in calcination. How could this happen? When he isolated the oxygen, he found many properties that were different from regular atmospheric air. This is when he discovered oxygen was the reason that calcination was occurring. Finally, he discovered that phosphorus increased weight when burning. When he decided to burn sulfur, he observed that the combustion of the sulfur and phosphorus weight is gained through the combustion and calcination. He said, quote, "I am persuaded that the increase in weight of metallic calves is due to the same cause." Robert Millikan lived from 1868 to 1953. He determined the size and found charges on electrons. Millikan did an experiment in 1909 that determined the size and the charge of an electron. He also discovered that the electron was the smallest unit of charge. Millikan's experiment was called the oil drop experiment, in which he would put a small charge on a drop of oil and then measure how strong an applied electric field had to be in order to stop the droplet from falling. First, he worked out the mass of the oil drop and calculated the force of gravity. This would then let him determine the electrical charge the drop was. Millikan, quote, said, "A drop of equilibrium method to determine the charge of the electron, E." He found a way to calculate the charge of any atom. Ernest Rutherford lived from 1871 to 1937. He populated the structure of the atom and found alpha and beta rays. The Rutherford model was a revised version of J.J. Thomson's plum pudding model of the atom, proving it wrong. Rutherford's new model was based on experiments that found there was a very high central charge concentrated in a small amount of volume in comparison to the rest of the atom. The small amount also contains most of the mass. This region would eventually be called the nucleus. Rutherford used an experiment that captured and used alpha particles emitted from the radioactive elements as probes to the world of atomic structure. By using alpha rays, he was able to see that there was a large mass in the center surrounded by a cloud, which are electrons. He proved that there was a very heavy and large central charge of an atom, which is what we know to be true today. Niels Bohr and the Bohr model. Niels Bohr lived from 1885 to 1962. In 1913, Niels Bohr produced the Bohr model, which proposed that his shell model was a representation of how electrons have stable orbits around the nucleus. Bohr's model was a correction to J.J. Thomson's and Rutherford's structure. Bohr was the first chemist to include quantum theory in his model, which describes the accurate properties of an electron in terms of its possible values of location, also claiming that electrons move in orbits of fixed size and energy, correcting Rutherford's model, as I said. The energy of an electron depends on the size of the orbit and is going to be lower on smaller orbits, closer to the center, the nucleus. Bohr found that the radiation occurs when an electron jumps from one orbit to another. The Bohr model was a massive discovery that allows us to calculate the different energies surrounding the nucleus in many orbital ways or shells. James Chadwick lived from 1891 to 1974, and he discovered the neutron. Chadwick was the man who discovered the neutron and was even part of the beginning predictions of a proton. In 1932, he used scattering data to calculate the mass of the neutral particle of an atom. He did this by bombarding boron with alpha particles, which are radioactive, and to analyze and observe the interaction of the neutral particles with nitrogen. There was an unknown left in the calculations, which is what he proved to be a neutron. Chadwick's discovery would go on to be very important in the creation of a nuclear bomb and nuclear energy. The discovery of penicillin by Alexander Fleming. Alexander Fleming discovered penicillin in 1928 by accident, but this would change the course of human health for modern-day medicine. Fleming discovered that a culture of Staphylococcus bacteria that he had left for 2 weeks happened to be contaminated. The contamination was preventing the growth of the culture. A pathogenic bacteria that later turned into penicillin, a modern-day antibiotic still used today. Penicillin is an antibiotic that helps the immune system fight antibodies that have saved millions and millions of people over the years. I know the title said Basic Overview of Chemistry Breakthroughs, and most of it was just explaining the experiment and how that discovery was founded. I wanted to tell you more of how and why it was such an important role in the advancements of chemistry in modern life to do these. But you really cannot quantify how much change they influence. Learning more about molecular life has brought us many forms of nuclear energy, nuclear warheads, a better understanding of elements and compounds to be used in the construction of buildings, and how the world works. And even penicillin, which was the building blocks of antibiotics that have saved millions of lives and keep us healthy today. These advancements stretch way further than the chemistry world. These people's discoveries shape the world we live in today. Here is my works cited. Thanks.